simple because it's just one color that we're going to look for. But I think kind of the cool part about it is that it has a direct clinical application. So the direct clinical application is this is the test that they use a lot to help diagnose people for ulcers, when they get ulcers, is they'll actually rely on the urease test. There technically is like a blood test you can do, which is not as helpful, and then there's another test you can do with stool, yes, but the urease test actually is pretty helpful for diagnosing people, so we're going to mention that. What I'm going to do is I'll draw this out on the board too, because my image I know is kind of fuzzy, but basically the enzyme that we're going to look for, all it does is it splits up urea. Is urea something that we have in our bodies? Definitely yes. So this is an enzyme that basically just uses water to break up urea. So the big question is like, where does the urea kind of exactly come from? So we get urea in our bodies as our bodies process amino acids. So basically, as we metabolize some of the amino acids in our diet, urea is kind of like a byproduct from that. And some bacteria can kind of use it as an additional kind of nutrient source. So the reason why they kind of created this test is because there's not too many bacteria out there that make urease. So this is actually also a pretty helpful one on the Unknown project because there's not like too many examples. I'll give you guys a few though. And then what's nice about this lab too is that you generally, when you get your result, it tends to be pretty straightforward because there's just two end products that get made. So one of the end products is ammonia, and then the other one's carbon dioxide gas. So we are just going to focus on the ammonia end products. So generally, people get a very clear answer, which is nice. So really, like the only thing is, I just want to give you a few examples of genuses of bacteria that make urease. Because I said it's not as like a common enzyme that a lot of bacteria make. So I have some examples. So as far as urease positive genuses, one definitely on the list is what we call Proteus. Proteus you guys have worked with a lot. Like we've worked with Proteus mirabilis, we've worked with Proteus, I think vulgaris. And Proteus is connected to urinary tract infections. So yeah, if you get a urinary tract infection with Proteus, Proteus can definitely use the urea in your body, in your urine, like as a source of nutrients, so has a huge advantage there. Another example is a genus called Klebsiella, and the real life application for that one is Klebsiella does have a connection with pneumonia. So pneumonia is kind of one of those infections. People can get pneumonia for different reasons, for sure. There's lots of bacteria that can give you pneumonia. There's viruses that can give you pneumonia. Klebsiella, though, is definitely one example, and that's a urease positive organism. And then I have to mention the strange name on the bottom that says Helicobacter. Helicobacter is basically the bacteria that's connected to ulcers. So I'll ask you guys, when you get an ulcer, what happens to you if you get an ulcer?
Bad pain. I've had one. You get bad stomach pain.
I know. So I was talking to two students from the morning lab, and they were talking about their ulcer experience. So I know it's painful, but I didn't know it was that painful because they said I couldn't eat anything.
You can't eat and
like anything.
I was throwing up blood and stuff at the end.
Yes.
And you lose a lot of weight too.
Yeah, because they were saying like they couldn't even eat bread or anything. Yeah. So with the ulcers, we've come a long way with ulcers because in the past we always thought that people got ulcers because you're really stressed or because of the food you're eating. And then not too long ago, we realized that actually has nothing to do with it. Stress can aggravate it, yes, but that's not the cause. So the reason why people get their ulcers is because they have a bacterial infection. And like the number one culprit is Helicobacter. That's the bacteria that causes the ulcer formation. And in like over 90% of the people, that is the reason why. It's like they have an infection and you actually have to be treated for it. So you have to be put on antibiotics to help clear it out. How do you get Helicobacter though? Like how do you, so you, at some point in your lifetime, you just accidentally eat it. So sometimes it shows up because it's associated with fecal matter. So a lot of people, get exposed to it like on accident. So it doesn't have anything to do with you being stressed. But we are going to talk about ulcers a lot in lecture. So we actually are going to come back and talk about Helicobacter because, the guy who discovered it, this was a couple decades ago. It was a big deal. He won the Nobel Prize for it. Because again, we have this misconception about stress and food. And then he basically showed that no, there's a bacteria that people are accidentally eating, and it's growing in your stomach and in your small intestines, and then basically like eroding the lining of your stomach and intestines. So when you get an ulcer, it's like an open sore. Right? It's kind of like an open sore that starts to build up. They can bleed. They're really, really painful. Really, really painful. And anyway, so the urease test can actually help to diagnose this condition, which is nice. So we're going to draw this out on the board, but the only thing to add for now is just to kind of keep in mind, it's kind of the same idea as the gelatin test. How we had, like we mentioned, some bacteria make a lot of liquid and some just do like a little crater form. Same thing for this lab. Some bacteria make a ton of urease really, really quick and your color is like super bright. Other times they're the bacteria like the Klebsiella a little bit slower. So you still get the color change. You can still read it, but it may not be like as vibrant. If this happens to you on the project though, and like you don't feel super confident about reading your result, you can definitely always put it back in the incubator. Just give it a little extra time. And then usually that helps a lot because just give it a little extra time to kind of change the color even more, and then generally people don't have any issues with it. So I just wanted to mention that in case that happens to you. All right. So for this lab, there's actually not a whole lot in the media. The only thing we're going to mention is that some of you guys did the tab, right? The urea tabs. And then one of you guys did the urea plate. The ingredients are the same though. So there's peptone, there's glucose. Technically there's some buffer that we're going to mention that's thrown in there. There's urea. Urea is going to be our focus. So to clarify, this lab, it's not a fermentation lab. Like, we're just going to home in on like one enzyme that breaks down urea, but it has nothing to do with fermentation. And then other than that, it's just phenol red. And this is I think this is the third time you guys are using phenol red. It's a pH indicator. And that's pretty much it. So we have the peptone, we have the glucose there, just kind of as like generic food, but we're not really gonna focus on that part of it. So, all right, and then we mentioned on the PowerPoint, you guys are just looking for one thing, which is kind of nice for this lab. So it's more straightforward. We just have the urea. Urea you get in your body when you metabolize certain amino acids. And then we said some bacteria can actually use it and metabolize it using urease. So it'll use water to hydrolyze urea. And then we said you end up with ammonia is one end product. And then the other one is, we said carbon dioxide gas. All right. So for this lab, all we're going to do is just read out the ammonia. We don't have like a derm tube in there or anything like that. So that's what we're going to read out, is just look for the ammonia. One thing I'll just say for now though, because in lecture we're going to talk about ulcers and the guy who discovered Helicobacter, because that was a really big deal. There is a test they can do in the clinic though. So more like in a clinic situation where they can do a test that's called the urea breath test. And the setup almost looks like a breathalyzer machine. So they have like this machine and this big tube and you like exhale into it. We're going to talk about that in lecture. So they can run the breath test on you and they can look for carbon dioxide gas, end product on your breath. And they can do that in the clinic. And it actually is like a pretty, it's a pretty accurate test. And what's really nice about this test is it's totally non-invasive. Like you just breathe out into the machine. It's not like they have to, it's not like a surgical procedure. It's very quick and very easy. So I had a student in the morning class, she said that's what they did to her to kind of, so what's nice is you can do it like before treatment, do the breathalyzer test, and then you can do it after treatment and see if the treatment worked. But anyways, for this lab, we're gonna look for ammonia. So it's gonna be pretty easy because we're gonna use the phenol red. This was the one that if you got acid buildup, you get like the yellow. If it's neutral, you get like the light red. And then if it's basic, which is what we're gonna look for, you get the deep pink. So for this lab, we're gonna look for the pink. I know for the other labs though, it was always looking for yellow because it had more to do with fermentation. But here we're just gonna look for the ammonia. And then the last thing is we have one little snafu because we do have peptone in there. And one thing we've been saying all semester long is that if your organisms eat peptone, a lot of times they'll make ammonia waste. So, in order to kind of prevent any confusion from happening, so we just want to see the ammonia from the urease. We don't want to see ammonia from the peptone. So basically they included that buffer so that if there's small changes in pH due to the peptone usage, the buffer will prevent your media from turning pink. So it'll prevent the pink development. So they included that buffer in there to kind of keep the pH a little bit more stable if your organisms are like slowly eating the peptone. So that way we don't get confused by the peptone. So we can be confident. If you guys see the pink, you'll know it's from the urease reaction. It won't be from just them eating the peptone. So I'll pull out your